Hey trigonometry students, this is your lesson on section 1.3. We're going to be looking at trigonometric functions and also a little bit more on quadrantal angles. So let's go ahead and get started. Okay, before I show you guys the definitions of our trig functions, or how we're going to define trig functions in this section, I want you to look at this diagram I have right here. First of all, here, what this diagram is of is an angle, okay, in standard position. And we have a point on our angle. And so what we're going to do for getting this distance r right here is this formula right here. So r is equal to the square root of x squared plus y squared. And this right here, that formula, is just the Pythagorean theorem. If you remember the Pythagorean theorem, it's x squared, well, a squared plus b squared equals c squared. C squared is, or c is always the value of your hypotenuse on a triangle. And see right here, we do have a right triangle. Whenever we draw a line downwards, and then this is your x, this is your y, and there's your hypotenuse. So this is just how you calculate the value of r. And whenever we go to the next page here in just a minute, you'll see that we'll apply these distances also, the values of x and y, to find the values of all 6 of our trig functions that we're going to be looking at. Okay, so let's look at the definitions. Okay, so here are all 6 of our trigonometric functions. And like I've told you before, this theta right here represents our angle. So sine of our angle, sine of theta, is equal to y over r. Cosine is going to be equal to our x over r. Tangent is our y over x. So y'all probably remember some of these at least these first 3 trig functions in your geometry class. And normally you hear sine of your angle is equal to opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, here, these are very similar. If you go back and look at that triangle that I had on the previous slide, you would see that these values of y and r and x and r match up to those definitions of trig functions. But in this section, we're not going to be looking at necessarily right triangles. We're looking at angles that are in standard position. So this is how you're going to come up with your values of all of your trig functions, is with these definitions here. So 3 things, or 3 trig functions that you probably have not seen before in a class, before this trig class, are these last 3 here. And cosecant of theta is equal to r over y, which is just the reciprocal of y over r. So if you know what sine of theta is equal to, just flip these 2 numbers and you've got cosecant of theta. And then the same goes whenever you compare cosine and cosine and secant. They are reciprocals of each other. So secant is equal to r over x. So just reverse these 2 values, r and x. And then cotangent, same thing goes on here. Cotangent of theta is equal to x over y, which is the reciprocal of tangent. Okay, so let's do an example. All right, so in our first example, we are asked to find the values of the 6 trigonometric functions of the angle theta. So here it is drawn out for you already. And how we come up with angle theta here is our initial side here is on the x-axis. And then our terminal side goes through the point 12,5. So we know that our x value that we can use to find this all these values of our 6 trig functions, our x is 12, our y value is 5, the point x, y, x, y, okay? That's how it goes. So on in your formula to find this value of r that is right here, we use this formula. Whoops, it's not squared, it's just r equals. So plug in x and y into this formula before we go and find all the values of our other trig functions. We need to find r. So plug in x, which is 12, square it, 5, square that, and then this is equal to the square root of 169, which is equal to 13. So now you have r equals 13, your x equals 12, and your y equals 5. Now use all of, let's just find sine, theta, then cosine, then tangent, and then find the other three. So sine is equal to your y over r. If you go back to that previous page I had on here, so y is equal to 5, r is 13. Okay, and then cosine of theta is x over r, which is equal to 12 over 13. And now let's find tangent. That is y over x, which is equal to, let's see, 5 over 12. Now, like I said, how you can find the values of the other 6 trig functions, do the reciprocal of the sine, cosine, and tangent. So the reciprocal that goes along with sine is cosecant. Switch these values right in here to find the value of cosecant. That's 13 over 5. Now the reciprocal of cosine is secant. And you get 13 over 12. And then cotangent of theta is equal to 12 over 5. Okay, so how you get all 3 of these last trig functions is you just change these values around. Okay, all right, so let's move on to the next example. Okay, so in this example, we're asked to do this same thing as we were in the last one, except now our terminal side, it goes through the point 8, negative 6. Okay, still we are not given the value of r. We must find that one. So plug it into this formula here. So x is 8 and y is negative 6. So we get the value of 100 inside the square root, which is equal to 10. Now we've got our x and our y and our r. Let's find all of our trig functions. So sine of our angle is equal to y over r. So this is negative 6 over 10. And go ahead and reduce any fractions that can be reduced. So this is going to be 3 over 5. Okay, now cosine of theta, that is equal to x over r. So put in 8 over 10. Then that reduces to 4 over 5. And then tangent. tangent of theta is equal to y over x. So place negative 6 over 8 and reduce that fraction. Get negative 3/4. Now, let's find the other three. Cosecant of theta is equal to, remember, just reverse these values. Still going to be negative though, so negative 5/3. Secant of theta is equal to, reverse these values of cosine, you get 5/4. And then tangent goes with cotangent is equal to negative 4/3. And we're done. Okay, I have two more examples to show you. And in this one, it's very much like the previous two, except this one, it still asks us to find all 6 trigonometric functions of angle theta in standard position. But this time, our terminal side is defined by this line right here. So here's the drawing of our line right there. And yes, this line will continue through here, but that's where this comes in. It wants all the values that are less than 0. So this is the portion of line that it's talking about. These are the values that are less than 0, not greater than 0. So this is the angle that we come up with. And now on this one, what we do to find values of x and y is you just let x be some x value, okay? It's any x value you want to pick for this one. And then you plug that x value in and you solve for y. And you have a value for x and y that you use for finding the values of your 6 trigonometric functions. Once you find x and y, then you can find r. So on this one, what I'm going to do is, but like on this one though, you must have an x value that is less than 0 for this to work though. So pick something less than 0. Let's just say negative 2. So I'm going to say let x equal negative 2. Then y is going to equal this. I'm going to plug in into our equation that was given to us the value of negative 2 and solve for y. And when you do this, we get the value that y is equal to negative 3. So when x is negative 2, y is equal to negative 3. Now that we have our x, y value, a point that is on here, so here's our point right there on our xy axis, we can solve for r. So r is equal to, again, I'm going to go ahead and write out that formula, x squared plus y squared. And when you plug in x and y, in here you get this right here. And that ends up giving us the square root of 13. Okay, at this point, leave everything in exact form. Do not give me decimal numbers on this. So keep it as the square root of 13. Now, let's find our 6 trig functions, since we have x, y, and r. All right, sine is x over r, so negative 2 over the square root of 13. Now, this form right here, our answer for sine of theta, that is not in the correct form that I want you to write it in. I want you to rationalize the denominator. Now, if you don't remember how to rationalize the denominator, watch this next step. You want to rationalize the denominator by multiplying both numerator and denominator by the square root of whatever is in the radical here. And whenever you multiply across now, you get negative 2 square root of 13 over, and then square root of 13 times the square root of 13 is the square root of 169, which is just 13. So it basically gets rid of the square root for you. So now you don't have a radical in the denominator, and this right here is the correct form to write that in. Okay, so now let's do cosine. Cosine of theta, you have a similar situation here. You get negative 3 over the square root of 13. Okay, if you follow what I did here in rationalizing that denominator, then you'll get negative 3 square root 13 over 13. Now let's do the tangent of theta, and that is our y over x, which is negative 3 over negative, oh, sorry about that, I had to stop my recording for a bit. But here, a tangent of theta is equal to negative 3 over negative 2, which is just 3 over 2, because a negative divided by a negative is a positive number. Make that 3 better. There we go. Now let's find the other 3 trig functions. So sine goes with cosecant, and that is equal to, now don't flip this value over here. You are going to want to flip this value over here, what you started with. Sine is equal to negative 2 over the square root of 3. Because if you flip this, you're just going to have to re-rationalize the denominator all over again. So take your first answer that you came up with, the one without rationalizing the denominator, and flip that value. So this is going to be negative square root 13 over 2. And then for your secant value, it is negative square root 13 over 3. And then your cotangent is equal to 2 over 3. And we're done with that one. Okay, so on this next example here, what we're asked to find is all the 6 trig functions of a quadrantal angle. And this right here, 360, is one of our quadrantal angles. Remember, the other 3 are 90, 180, and 270. And we'll look at another quadrantal angle on the next slide. So this one, 360. Let's find all 6 trig function values for that. Now, we can go through the formula for finding r, but really it is not hard at all to figure out what r is. R is always going to be the other number that is not 0 in a quadrantal angle, except it's always going to be positive. Your r value is always going to be positive. So let's look at that. We have 2 squared plus 0 squared. Well, that's just 4 squared. So back at 2. Okay, so just remember r for a quadrantal angle. Just take the other number that's not 0 and make it positive. That's your r value. Okay, so let's do sine of theta. That is your y over r. So 0 over 2, which is just 0. And cosine of theta is your, let's see, x over r. So 2 over 2, which is 1. And then your tangent of theta is equal to y over x. Let's see, y over x. 0, sorry, I didn't mean to write theta. 0 over 2, which is equal to 0 again. Now let's look at the other three by taking the inverse of all these other three values we found. So cosecant of theta is equal to the inverse of this. So flip it over, you get 2 over 0, which is undefined. I'm going to just abbreviate it as UND, undefined. Now on cosine, which corresponds to cosecant, you get the same value, 2 over 2, which is just 1. And then cotangent, again, flip these values, you get 2 over 0, which again, undefined. Okay, so I'll show you a page here in just a minute that shows the values of all 6 trig functions of all quadrantal angles. And you'll see that there's a pattern that develops here. Okay, so again, this is a quadrantal angle of, this is 270 degrees. But let's find all of our trig function values. That's what we're asked to find. Our r is going to be, well, the positive of this number, so just 5. So this is our x and this is our y. We'll plug it in to each of these 6 functions. So sine theta, y over r, so negative 5 over 5. That's negative 1. Cosine is, let's see, x over r. Yeah, x over, so 0 over 5. That is 0. And tangent of theta is y over x. So negative 5 over 0. And this ends up being undefined. Now, let's do the other three. Cosecant of theta is equal to, take the inverse of this, still going to be 5 over negative 5, which is still negative 1. Secant, take the inverse of cosine, you get 5 over 0, that's undefined. And then tangent, cotangent. Cotangent of theta is equal to, now this becomes 0 over negative 5, which is 0. And we're done with this one. So now let's look at this next page. So notice on this page, we have all 6 of our trig functions, and then these are all of our quadrantal angles between 0 and 360. One thing that you could see is all of your trig functions, the values of it for quadrantal angles are going to have the value of either 0, 1, undefined, or negative 1. Those are the only 4 values that quadrantal angles can be. So just take a look at this page here and So the next time you're asked to find values for uh, your trig functions of quadrantal angles, you can look back at this right here, and there you go. There's all 6 of those for you. Okay, so we will be going over this in class tomorrow. So I'll see you then. Goodbye, everybody.